Well, thank you very much, and hello. I'm Miranda Sharp, and I chair the Commons stream for the National Digital Twin Programme. And today I'm going to talk about how we can use data to enable a new data economy and for good. Now, this picture was taken when I was on holiday in northwestern Namibia a few years ago, and it relates to prehistoric rock carvings that are found in this area. And I love this picture because for this civilization, this was the perfect digital twin. It is data presented on the form of rock carving, which shows persistent and seasonal watering holes, which are accessible from that stone. And the data is presented precisely to meet the needs of the user in a format that means something to them and on which they can take action and achieve better results through taking better decisions. And we often talk about data, we talk about it in the form of it being visualized. And when we visualize data appropriately, we can make a better set of decisions. So I show you this graph, which is of Sheffield, and it shows this map, which shows a worrying correlation between health and wealth. So this is census data, so it's self-reported data. And people who live in the darkest, greenest houses are reporting the best health. One of the questions you fill in on a census is how well are you? And the people who live in the darkest, reddest houses are answering that they are the least unwell. And then in the shaded polygons, the people who live in the darkest areas are living in the areas of highest deprivation, and the people who live in the lightest areas are living in the areas of least deprivation. They're the most well off. And what we can see by putting these two data sources together is we can see the alarming correlation, as I referred to, and that might lead us with that better information to make better decisions for, about possible interventions, and with that, better outcomes for the people involved. And that's all very well, but we're now working with increasing amounts of data. So it's not just that we have more data relating to different people from things like census, but all the sensors, which we carry around, a lot of them in our phone, are giving us new sources of information. And how might we use those new sources of information so that we get better outcomes for people? Now, one of the sources of information we're looking at here is sensors relating to bike lights. So what this now shows us is aggregated bike travel. So it shows us how fast people are moving around the City of London. So we can see, for example, relatively easily that people whiz up and down the embankment on Cycle Superhighway 3, that's to the north side of the river, in the bend. And also in the top left-hand corner, people whiz around the circle in Regent's Park. And this is a new form of data which gives us information on which we can make decisions, for example, on things like cycling infrastructure. That's data that didn't exist before. And the challenge now is how to integrate that data and how to use it in the best possible way. And that is where often people start talking about digital twins. How can we make a digital simulation of a universe so that we can make better decisions for people who operate those assets and for people who use them? So I'm going to talk a little bit now about what a digital twin is. Now, a digital twin is a digital representation of something that is real. And notice I didn't say physical, I said real. And what there is a two-way relationship between the real thing and the digital thing. So that we take readings from the real thing, we can model it in the digital world and make interventions in the real world. And in this example, we're talking about a train carriage, and you can imagine how a digital representation of a train carriage allows you to make better preventative maintenance, enables you to do virtual training and therefore increase the safety of your employees when they're on site. And you can compare the same assets which are in different environments and see what effect that has on the performance of your asset. And once you've got the digital twin of a single asset, it sort of makes sense to link that digital twin to other bits of the system in which it operates. Now, in this example, the train carriage, the twin of the train carriage it was linked to the signalling system and the track and the timetable. If we link those all together, we're going to get a better customer experience, and also might get an efficient railway. And you can see it's relatively easy to see the arguments for doing that. And of course, once you've thought about that, then by extension, you start to think about the city or the place as a whole cyber physical system. And you can, when you start linking up many different systems like this, you can start making those very difficult trade-offs and in a data-informed way. So, for example, how much water should we use to make power, or how much power should we use to make water? How do we tackle pandemic response? How do we reduce the amount of carbon in the supply chain, for example? And you'll notice here that when I'm talking about the cyber physical system, I'm not just talking about the very small amount of the system which is under construction here in the top right-hand corner. We've got to think about instrumenting the existing assets every bit as much as we think about instrumenting the new, because we've got over 99% of the infrastructure that we will need in the next 100 years. We're only going to be adding relatively small bits to it. Now, as I've been talking about this, your head's probably been popping with use cases about how you might use a twin for very good reason. You might have very good reasons for an individual organisation to create a twin, like I said, about safety or increased productivity or customer satisfaction. And when we in the National Digital Twin Programme started out, we didn't define what we thought would be the best use cases. We started with principles. And we're trialling these principles at the moment. They've been internationally acclaimed, so that people build digital twins based on clear purpose, with trust and with function. Now, these principles aren't an easy tick list because they have tensions within them. So each digital twin will have to make decisions about how they balance security and openness, how they do public good, but also create value. And we're interested in talking to people who've been creating digital twins and how they've managed to achieve a balance against these sorts of principles. But that's what we've been doing. And I like to talk about an example of when a digital twin would have been a really good idea, and particularly a connected digital twin. Now, I would like to tell you the story of this road. As you can see, this road connects two bits of a community. It has we've got the blue addresses are residential addresses, and the red addresses are businesses. And we can see churches and allotments and schools, which are also on this map in the big coloured blobs. Now, it's not unusual for a road to carry out other functions. And not only does it contribute to the movement of goods and people around a community, but it will also, for example, be used in the subsurface will be used. It's a nice straight area for the carrying of utility services, and the space above it will often be the same. There'll be natural capital alongside of the road, which will contribute to the overall health of an area, and we'll also get social capital on the side. For example, shops and places where people meet will often be served by a road. Now, in this particular example, the road crosses a river, and even more in that case, it's not unusual for the bridge to carry a number of ancillary services. Now, the sharp-eyed amongst you will notice that we might remember that Tadcaster was the scene of a famous bridge collapse following a flood. And in this particular instance, everybody knew that their pipe was on the bridge, but nobody knew that everybody's pipe was on the bridge. And so when it was washed away, there was a great deal of disruption, not only for the good people of Tadcaster, but nationally, because there are a number of nationally important cables going across that particular bridge. And if we'd been able to connect the data in advance, we might have put further remediation measures in place so that that bridge was best protected. We might have observed it more, and in fact, retrospective observation has revealed that this bridge was behaving in such a way that its collapse was not unpredictable. And if we'd done that, we might have saved a great deal of money and time. And so there's an example when it would have been good, and when we might be doing it better, for example. Another one is a pilot that we're in the midst of with the Geospatial Commission, where the Geospatial Commission are working with two consortia, trying to avoid this kind of disaster when somebody digs a hole and wipes out the services convened by that particular cable. There's also a very important role of workplace safety in here. Certainly at the moment, we're seeing the early examples of connected digital twins being taken for workplace safety, where the case for the barriers to sharing data must have to be lowered because the argument for safety is inarguable. But it's quite difficult to understand precisely who benefits when digital twins are connected. And so I want to take you through this framework that we've developed at CDBB to help us explain and describe who is going to benefit from connected digital assets. So in the first example, we're thinking about a stakeholder, for example, a local authority, performing an activity on one of their assets, so for example, a road, and therefore deriving benefits. So the local authority has to maintain the road in order that it can move goods and people, and then it gets benefit back to the stakeholder. In the next example, the asset is accompanied by an isolated digital twin. And there we have the local authority might do some what if planning with their digital asset, so they can decide the best time, for example, to resurface the road that inconveniences fewest of the shops, that maintains most of the tree's integrity, and they will get benefits from doing that. But once we connect the digital twins, so for example, we might connect the road digital twin, so that's the surface road digital twin, with some of the underground assets. Not only will those two organisations be able to collaborate and perhaps reduce the cost and increase customer satisfaction in their joint operation, but there will be other people, other stakeholders who will benefit, and will get an even greater amount of green benefits cogs turning and giving value. And now that we've got this framework, we think we're able to establish precisely how much value is going to be generated and who it's going to be generated to. And that's something else we're going to be looking to test in the coming months. We've got this ability to test it, but up until now, there's been a lot of argument for just making data transparent or giving it away as open data. We often hear the example of Citymapper quoted to us as a business which has thrived on the use of open data. Not only has it thrived, but it's been done a great service to many of us, and certainly there's a lot of evidence that people no longer queue for buses because we have a much better understanding of the bus network, and we can stay inside and keep warm or cool while waiting for the bus to arrive. However, one might also argue that the data asset that TfL gave away by making its data open should have had some conditions attached to it, so that Citymapper weren't, for example, able to approach TfL after a few years of operation and suggest that it now had data assets which could be sold back to TfL so that it could design a better network. So I think we're coming into a world where we're much more nuanced in the care of our data assets. I think about this web, or you think about this web, this value web, when we're thinking about data. So there's lots of data around. Some of it will be given away and be useful to you and your partners. And it's about who you connect with and where you're going to get the value that will drive our decisions in the future, and perhaps how we care for our data assets and with whom we share them. Now, I want to finish with one final anecdote. We imagine this world of completely frictionless sharing of data that enables value to be created by our suppliers or by our subcontractors, and they will make much better use of it than us. But I think it's worth remembering that data always has the story of its collection within it, and therefore it has within it some of the stories of failure. So this is a map which was surveyed by my dear former colleague at Ordnance Survey. And the first time he surveyed this particular line of pylons to the southwest in Scotland, he surveyed it very carefully. And when he went back to review his work 5 years later, he was horrified to discover that the pylons were in the wrong place. And he was absolutely sure that he'd put them in the right place. So when he rang head office, they explained to him that the pylons at either end where the wire changes direction are placed absolutely accurately, but those in between were spaced out evenly because it was much easier on the eye. Now that was the early 80s, where cartography was much more important than accuracy. Now rest assured, it's been attended to since. But quite often when we start using data, we have to be aware of why it was collected and what good it was intended to do at the time, and whether or not that serves the purpose for which we're now using it is a question that we should all be answering. So that's what I have to say. Thank you very much. I've got some useful links here relating to sustainable data institutions and work that we're getting on with at CDBB. I'm happy to take any questions or do follow up with me afterwards and see if you can help with our ongoing research. Thank you very much.